More than a century ago, welders first fused two metal surfaces by melting a metal stick over them using an electric current. That stick is now called a welding electrode. It's the simplest and most popular way to weld. Farmers and mechanics often use this tool to repair heavy machinery. This company's electrodes are coated with powdered metals and minerals. During welding, the metals melt and the minerals protect the area from oxygen, which would weaken the bond. The electrode transmits an electric current that heats and melts both the electrode and the metal surfaces, welding them together. Thin metal wire forms the electrode's core. The kind of wire depends on what the electrode's designed to weld, but most often the core is made of carbon or stainless steel. A machine simultaneously spins and bends it, evenly reshaping the wire until it's completely straight. Four metal rollers then push and guide the wire into a guillotine. The blade chops the wire into segments that'll become the electrode cores. These segments range from 10 to 17.5 inches long. The factory puts a variety of metals and minerals in the coating. The metals are often nickel, manganese, and iron. The minerals, alumina, magnesia, and limestone. They also add a colorant to differentiate the models. Workers mix the ingredients with a bit of glue until they turn to the consistency of wet sand. The worker then packs the mix into a machine that forms it into slugs with a hole down the middle. He adds a plastic cap, then a metal cover slides on and the machine takes over. It takes only a minute for the machine's piston to compress the powder into a solid. Now to put the powder coating on the core wires. A worker loads 4 slugs into an extrusion press. It'll apply 120 tons of pressure on the slugs to shoot the powder through nozzles that'll coat the wires as they pass through the slug's hole. To load the wires into the press, they first stack them in this feeder. The opening at the bottom is adjustable for different diameters because core wires range from spaghetti thin to pencil thick. These rollers pass them through the press one at a time. Four wheels then pull the wires from the feeder into the extrusion press for coating at a rate of up to 1,000 electrodes a minute. When the coated electrodes emerge, they hit a metal wheel that positions them on a conveyor. A sander removes up to 2.5 inches of coating from the bottom, where you grip the electrode, and it bevels the tip so it conducts electricity even better. A worker now checks for uneven coating and to see if the wire's well centered. The coating dries at room temperature for up to 72 hours. To cure the coating, workers put the electrodes in an oven heated to 905 degrees Fahrenheit for up to 5 hours. Once they've cooled, the electrodes head into a printing press. An ink wheel first prints the model and type of current that's required. Another ink wheel then applies a color to the gripping end. It's another way to differentiate the model in case the lettering on the side rubs off in storage. From there, it's off to packaging. An optical scanner counts the electrodes, then a stacking machine separates them into 7.7 to 11-pound bundles. Finally, a worker inserts them into cardboard canisters. He adds a piece of cardboard to compress them tightly for the trip. A sticker marks the contents and tape keeps the package tightly sealed.